Hi everyone, welcome back to Cooking with Cody. So today I'm sorting through my potatoes, which have come from my gardening series. You can see here I've got a big box full of the A grade, the large eatings potatoes. Down here I've got some of the B and seed grade potatoes. Over here I've got the probably the D grade. They're a little bit damaged and maybe starting to rot, and these over here are the Fs. They are already rotted essentially. These will probably get thrown either into the compost, garbage, or I'll throw them to the chuckers. They might eat them, but I'll finish sorting these out later. But I think today we're actually going to focus on these ones here. Let's see if we can make something from them. So the first thing I'm going to do is peel and cut most of the bad parts off of these potatoes. I don't know why, but this cat really likes potatoes. So there's the peeled potatoes. Looks like I got 3.33 kilograms of it. So now what am I going to do with all these potato pieces? They are quite edible. I could certainly boil them and turn them into mashed potatoes like I did with the other batch of rejects, which was quite good. Or I could do something a bit more sciencey and extract the starch and turn it into sugar. I think that sounds like fun. So let's get the starch out. They're thinking about it. Alright, so here we are, the ground up potato stuff. It looks like it's pretty fine, but I think I'm going to run it through a sieve, if I can, and grind the larger pieces again. And I think I've extracted most of the starch already. We just got to get it separated from this pulp. Starch is quite heavy, so it settles out of the liquid. You can see my crude starch right here. Yeah. Here's all the fiber that I separated out of it. And this potato water. If you're serious about getting some potassium, drink this. It's got way more than a banana would have. To wash it, I've dissolved the starch into water again, and I'm going to pour it through a screen into a settling column. So it's the next day and I've successfully washed the starch, so it's mostly clean now. There is a dark layer of something in here. I'm not entirely sure what that is. You can see it settling out multiple times in this exact same position in the time lapse that I'll put in the end. If you know what that is, please let me know. But let's dig this out of here. So, just like this. And let's put it into this bowl that I got right over here. So here's the starch. It's still wet, so I don't really know what it weighs, but this has got to be at least a pound of starch here. So I think I got a pretty good recovery. Or either that or they were really starchy potatoes. The dark pieces, they do appear to be a little bit purpley. So maybe the dark colored starch is due to the purple potatoes, and it settles out at a different time, maybe because the particle size is a bit different. That's my working hypothesis. Let's turn this into sugar. So to illustrate what I'm going to be doing, let's take some pieces of noodle here, and let's call these our glucose molecules. C6H12O something. And these glucose molecules, in order to form starch, which I'm representing here by these longer noodles, you have to stick them together. But in order to stick them together, you have to remove water from the bonding area. So as they come together, water is formed. So that water is leaving the system, and these glucose or sugar molecules are linking up. Now to split them back apart, you have to add water back in to cut them apart. You know, break the starches into sugar. Now, enzymes can do this, or it can happen just naturally in water, because water likes to get into things. But it will happen a lot faster if the water is of a low pH, so it's very acidic, or if the temperature is very high. I am going to do both of those things and put this in an acidic, high temperature environment. Potato black. That's about the same stuff as cornstarch. They're both starch, so I would expect that. Alright, so I'm going to pour the starch off into a pan and add some water, because the hydration reactions do need quite a bit of water. Also, I don't want the starch to get too goopy while I'm cooking it. Alright, so the pH looks like it's around 6.3 right now. So I want to lower that to approximately 1.5. Probably a little bit below 1.5. So I'm adding some hydrochloric acid, which is the same type of acid as you have in your stomach. I think vinegar or cream of tartar could work for this, but I've never tried it. Sulfuric acid would be the best for this because it's fairly easy to remove, but fortunately I don't actually have any sulfuric acid that is food grade at the moment. Now that I've acidified the mixture, I'm going to tip it over into some 1.5 pint jars. This is because my pressure canner is made of aluminum, which really can't handle the hydrochloric acid. The idea is that the high pressure will keep the water from boiling until it reaches a higher temperature. You know, the higher the temperature, the faster this will go. In fact, for every 10 degrees Celsius I can increase the temperature, the reaction rate should roughly double. Possibly even more than that. So, you know, adding around 15 degrees centigrade through putting it in the pressure cooker, yeah, that's definitely worth it. As it is, it's going to take a really long time. Now I can already hear you guys asking, well, why go through all this trouble? Why not just throw in some malted corn or some amylase enzyme? And yes, that is the first step into producing fermentable sugars when you're making vodka from potatoes, but the problem with that is the sugar produced is maltose, and maltose isn't particularly sweet. And I don't know if you've ever had malt extract, but it's not very good on your pancakes. So I'm doing this, and I'm going to produce some glucose syrup, which is much sweeter. And we're rocking. I'm going to let this pressure cook for about 2 hours, so see you then. Well, looks like we're getting there. Been in for 2 hours. Probably shouldn't do that. Alright, pressure's off. Let's open this up. It looks like it's no longer gelatinous, so I'd say we're done. It is now sugar. Of course, there's still quite a bit of water in it, so we're going to have to boil it down. I actually canned it, didn't I? I'm actually going to pour off most of the top, leaving any sediment at the bottom. Yeah, I think I'll leave about that much. There's still some stuff that didn't dissolve. Now this mixture is still very acidic, so I'm going to neutralize the acid with a little bit of sodium hydroxide. This will react with hydrogen chloride to form regular table salt. In fact, if you look on the ingredients of, say, some corn syrup here, you'll see salt is listed as an ingredient. You ever wondered why? Alright, looks like the pH is around 1.2, which is about where I just left it. So let's put in a little bit of diluted sodium hydroxide, give this a stir, and we'll watch the pH come up. Alright, that's pretty close. I don't trust this pH gauge a whole lot, but let's just take a little taste of this. Okay, it doesn't taste acidic anymore. It does, however, taste sweet. Alright, so I think that is my syrup. It'll probably get a little thicker once it cools. But that's it. That's definitely a syrup. I was starting to burn it, that's why I shut it off. And when I did. Let's grab a sample of this and have a taste test done. Hey Canyon.
What's up?
I got something for you to taste test for me.
What is it?
It's my potato syrup.
It's gonna taste like potatoes?
Maybe. Actually, no, I've tasted it. It doesn't taste anything like potatoes anymore. What do you think?
Definitely sweet.
Yeah.
Kind of caramely.
That's probably because I burned it.
Oh, okay. And maybe a little nutty.
Nutty? I would say it's got a little bit of even like fruity type.
Yeah, I could see that.
And it's definitely got a bit of a bitter like aftertaste. Like it's really sweet up front, but
it's not bad.
No, I definitely could eat it. Actually, it kind of resembles, that's probably because it's basically glucose syrup itself, like that pancake syrup, the fake maple stuff.
Oh, yeah, I can see that.
Yeah.
Mm-hmm. You gonna put it on some pancakes?
Do we have any pancake mix stuff?
Check the cupboard next to the fridge.
So I've transferred my potato syrup into this jar. Looks like 350 grams in what looks like 270 milliliters there. So yeah, it's definitely denser than water. It is a syrup. Look at that. That's actually a rather small amount, really. Volume-wise, it's, just over a cup there. And that was taken out of 3 kilograms of potatoes. Obviously, I will have had losses, but this is a really concentrated form of potato calories. Because I'd imagine most of the calories in the potatoes are sitting right here. And you could chug this, or pour it on your pancakes or whatever. Kind of shows you how, eating syrups and stuff can really make you fat. And this has got none of the fiber, protein, or vitamins. Anyway, hope y'all enjoyed. I'll see you next time.